Hi again, everybody. So let's take a look at how to do the and probabilities when we have dependent events. So this is when what happens first changes the probability of what happens next. So dependent events. And to do this, you're still multiplying, but now you have to think about, well, how does the probability for the next event change after I do the first thing? Like maybe I'm drawing a marble out of a bag and I'm not putting it back in. Well, that's going to change the probability that the next marble is a color or something. Or you'll see I'm going to do an example with cards, like dealing cards. So the rule here is that you're going to multiply to get the probability of A and B. You multiply the probability of event A, the first thing, times the probability of event B given that A occurs. That's called a conditional probability. So let's take a look at a couple of examples here. Let's say we're dealing cards and without replacement. So the without replacement is the key here to recognizing that you have dependent events. Because if you draw cards, once you pull a card out, you've now changed the probability for all of the other cards because you don't have 52 cards anymore, you only have 51. And if you deal another one, now you're down to 50, etc. So let's take a look at this. What is the probability that you draw an ace followed by a jack? So this kind of wording means it's an and. So what we're doing is we're doing the probability of getting an ace and a jack. So an ace followed by a jack. Well, that is going to equal, so it's an and, we know we're multiplying. So that will be the probability of getting an ace times the probability of getting a jack given that we just got an ace. So I'll just write given here. So let's think about how this works. I don't know what happened there with my A. Okay. So the probability of getting an ace, well, we've gone over the cards. So there are 4 aces in a deck of cards. So we have a 4 out of 52 chance of getting an ace. But now imagine that I gave you an ace and you're holding that in your hand. Well, now the probability of getting a jack, there are 4 jacks, but there's not 52 cards in the deck anymore. There's only 51. So the probability of getting a jack changes once you are dealt an ace. So this is how we do this probability. And then taking a calculator here and doing 4 divided by 52 times 4 divided by 51 gives me 0.006. So it is very unlikely that you would get an ace followed by a jack. This is 0.6%. All right, let's try another one. What is the probability of getting 3 hearts in a row? So this is the probability of getting a heart. Of getting a heart and a heart. The system really wants to make those circles. And a heart and a heart. Now again, we're not replacing the cards. So the probability is going to be the first time when I go to get a heart, well, how many of the cards are hearts? Well, that's 1/4 of the deck. So 52, when we split that into 4, there are 13 cards of every single suit. So there are, and if you have problems, if you come across any of these card problems, just do a quick Google search of a deck of cards and you'll be able to very easily see what's in a deck of cards. So there are 13 hearts in a deck. So the very first card, we have a 13 out of 52 chance of getting a heart. But once we've pulled one out, there's only 12 hearts left. And there's only 51 cards in the deck. And then when we go to get the third heart, assuming that we just got 2, well, now there's only 11 hearts left. And there's only 50 cards in the deck. So this is how we'll calculate our probability. And again, I'm taking a calculator here and multiplying, and we will get 0.0129. So about a 1.29% chance that you would get a heart followed by a heart followed by a heart. All right, let's do one more example here. Ernie has a pile of 10 jelly beans made up of 3 red, 2 blue, 1 orange, and 4 green. What is the probability that he selects 2 jelly beans without replacement? So again, this is how I know I have dependent events. And he ends up with a blue followed by an orange. So we're looking for the probability of getting a blue and an orange, and we're not replacing the jelly beans as we pull them out. So that is going to be equal to the probability of getting a blue times the probability of getting an orange, given that we got a blue first. So let's see what that is. Well, for the blues, there are 2 blues, and there are 10 jelly beans. So he has a 2 out of 10 chance of getting a blue jelly bean the first time he reaches in there. But now he's got the blue one and he's not putting it back in. So now we're looking for the probability of getting an orange jelly bean. Well, there's 1 orange jelly bean still left, but there's only 9 jelly beans in the bag because we already got that blue one. So our probability here, when we multiply, is 2 out of 90, or if we wanted to look at that as a decimal, 0.0222 repeating, or about 2.22%. Okay, and that's how you do probabilities with dependent events. So you've got the 3 videos to watch, the 1 YouTube video and then the 2 also YouTube videos, but the ones that I created. So we're going to practice this multiplication rule for a couple of days. Just let me know if you have any questions, and good luck, everybody.